So 17 bonus questions are a really good question because it's what we're doing really close to Christmas. I mean, I still got a whole nother unit to cover for Christmas, whether you like it or not. We're 2 weeks behind pace. Only I finished this particular section up next week. In the last 2 years, I've had a midterm. So, you don't have to have a midterm. You have that. Anyways, this is read f composed of g. That means that every x in function f becomes function g. And I'm a big fan of the old school, which is parentheses. That notation right there looks like this. Okay. Now, what is g of x? Well, this is g of x. So what I'm actually finding is f of 10 over x. And again, that means that every x in f becomes 10 over x. So I'm looking at function f, I see a 10, then I see an x, and by God, it becomes 10 over x, and then plus 10. Now, this is what we call a nested fraction. And that's what it's called. It's called a nested fraction. It has fractions and fractions. To clear a nested fraction, you multiply all terms by the denominator's denominator, by the denominator's denominator. So what I'm going to do is I'm going to x everything. Everything gets multiplied by an x. 10 times x is 10x. Now, think about 10 over x times an x. X's cancel. That becomes 10. And then plus 10x. That's how hard that is. Bam. Easy peasy lemon squeezy. Number 18, divide x to the fourth plus 625 by x minus 5. The easiest way to do that is synthetic division. It should come out and work nice because of how x to the fourth plus 625 factors. But we'll find out. Now, so if we're dividing by x minus 5, x is 5. We're going to use placeholders. 1, there are no x cubes, there are no x squareds, there are no x's, and then you have a 625. And we're going to drop the 1. Oh, actually, it doesn't work out. 5 times 1 is 5, 5, 25, 25, 125, 125, 625, and 1250. So remember, remainder, constant, x squared. We're left with 5x squared plus 25x plus 125 plus 1250 pieces of x minus 5. That's not hard. It's way easier than some of the questions you just did on your test. It really is. Let's see, number 19, compute the discriminant. You probably don't remember what the discriminant is. The discriminant is b squared minus 4ac. And if equal to 0, you have one real repeated solution. If less than 0, you have two complex conjugate solutions. Let's use the word conjugate. These are imaginary, kids. And if it's greater than 0, you have two unique real solutions. It doesn't say find the solutions. First things first, this thing's got to be set equal to 0. So it becomes 6x squared plus 8x plus 7, now equal to 0. And all I'm worried about is the b squared piece, minus 4ac. So I pick out a, b, and c, and I just go to town on it. It'd be 8 squared minus 4 times 6 times 7. And this is going to be negative, by the way, because that's 64 minus, lost my place here. $168. And that is negative 104, and that is definitely less than 0. So compute the discriminant. I did that part. Determine the number and type of solutions. We have two imaginary solutions. It's just a different way of wording what I wrote up here. Two imaginaries. All right, solve the system of equations. We've done this, actually. We have. What's the quickest way to do this one? That's a darn good question. Because this one, if you do it one way, you get fractions, and if you do it another way, you don't. So on this one, I think what I'll do is I'll solve this equation for x. X would be 2y plus 3. So everywhere I see an x, I'm going to become 2y plus 3. It's going to be a 2y plus 3 squared minus x, which is 2y plus 3, times the y, which is 20. Now remember, when you do 2y plus 3 squared, you got to write that bad boy twice, and you got to FOIL, or draw a box. I'm just going to FOIL it. 4y squared plus 12y plus 9. Let's see here. Let's handle this first. Minus 2y squared plus 3y, still equal to 20. Now let's distribute that negative. Let's just put this together. 4y squared minus 2y squared is 2y squared. 12y minus 3y is 9y. We still have the plus 9, still equal to 20. Got to set equal to 0. 2y squared plus 9y plus minus 11 is a 0. I think that'll factor. To create a 2y squared, it takes a 2y and a y. To create an 11, it takes an 11 and a 1. 1. Let's see here. We want plus 11 minus 2. Factored. Sweet. ZPP, 2y plus 11 is a 0, so y is going to be negative 11 halves. Or, this one's easy, y is 1. If you don't understand y is 1, what have you been doing with your life, kids? Because I don't know. I really don't. All right, let's plug these things back in. So x is going to be twice a negative 11 over 2 plus a 3. And that's going to be 2's cancel, negative 8. So I have an ordered pair, negative 8, negative 11 halves. That's a solution. That's where the graphs would cross paths. Or x is going to be 2 times a 1 plus a 3, which is a 5. So I have the ordered pair 5, 1. There's your twin answers. Easy peasy. It is to me. Hopefully it becomes easy to you. All right, solve the rational inequality, express the solution set in interval notation. It's really not in your Algebra 2 standards anymore. So let's just do it this way. Let's look at a graph. Yeah, that's how we're going to do it. Math, num, n over d. I keep telling y'all not to use the shortcut on your faceplate, but y'all aren't listening to me. So what's going to happen is, come end of course time, you're going to get somebody else's calculators, and they don't have the shortcut on your faceplate. But you don't listen. Don't listen to the 45-year-old adult. Don't do it. Now, I've got a 0 in y2. Zoom 6 that bad boy. We'll talk about the graph. Oh, it only has 2 answers. Sweet, and they're easy answers. They really are. Wow, they're easy. If you know how to read a graph, which is obviously an issue. Now, the deal was being bigger than 0. And that is happening from here to here and here to here. I do want to go back and play with my window a little bit. I'm a little curious if there's some parts of this graph that aren't being shown. Well, yeah, I know it's not showing something. I had to think for a second. I'm going to change this Y max to 100. Maybe you can see it. There's going to be what we call a vertical asymptote right here at x equals 1. And, you know, maybe for some of you kids who pay attention, x can't be 1. Because if it was, you would divide by 0. So what happens is this tail runs all the way until it hits 1, and then it hits what we call a vertical asymptote. So this tail starts at -10. You can count just as well as I can. And it runs until it runs into that 1. Oh, I get to be a bracket there. Can't be a 1 though. Then it restarts on the other side down here. Oh, nope, sorry, not paying attention. Then the positive tail starts here at 8, bracket on the 8, and it runs right forever all the way to infinity. I'm going to pause, be right back. I think my wife's messaging me. Got to take those. Got to. It's probably just TikTok, to be honest with you. All right, so this is also coming up next spring. Solve equations like this. Now, here's how this works. There's a little theorem. It says if, I wrote is, if some base to the x is equal to another base to a y, x equals y. I want you to notice those are the same. We're going to rewrite 32 as a power of 2. 32 is 2 to the 5th. And we already had an x up top. 2 to the 5x equals, okay, so you're about to learn this next week. 1 over root 2 is 1 over 2 to the 1/2, which is 2 to the -1/2. So what you can see is I've satisfied this requirement right here, that the bases are both 2's. Turns out now that 5x is -1/2. Divide by 5. Division happens in the denominator. X is -1/10. Such an easy problem if you have number sense. It's a big if. It is. I know it is. All right, solve the equation 4 to the x plus 4 equals 5 to 2x plus 5. Not an easy problem. But I don't want to teach you how to do this on logarithms. At any point in your life, and we could have done it on the last one too, by the way. It's worth showing you. Watch this. 32 to the x, enter, 1 divided by squirt 2. Zoom 6. This is going to be your 32 to the x. And 1 divided by the square root of 2 is pretty small. There she is. Next move, second trace 5 for intersect. Enter, enter, enter. By God, there it is, -0.1, which is -1/10. Anyways, I don't feel like teaching the next bonus with logarithms. For one, I ain't got that kind of time. And it is a logarithm problem. It's also a fairly difficult problem to do with logarithms. I'd call it intermediate. A lot of times kids see logarithms in their high school and they're like, man, that's hard. We didn't show you hard logarithms. We did not. Anywho, still a Zoom 6. There's 4 raised to the x plus 4. Incoming is 5 raised to 2x plus 5. And the solution's probably happening somewhere over here. And there's a good chance that I'm going to have to look left to get it. Let's see. Second trace 5. I'll get my cursor down there. I'd be surprised if the answer shows up. Enter, enter, enter. Oh, wow, it did. There it is. The solution was actually up here. It wasn't down here. My bad. It was up here. So it was at -1.3653. Huh. Yeah, the red one is going to catch the blue one, isn't it? -1.3653. Again, that was a y1, y2 thing. X equals -1.36, what'd I say, 53 maybe? That seem legit to you? Yeah. 32, which is the last bonus question. Write the equation in STD form, then give the center and radius of the circle. So here's what you're going to do. You are going to do the complete the square technique twice. Believe it or not, this is actually a geometry standard, and it is unlikely you actually did it. because way too many teachers think that completely the square is too hard for you poor little children. But what you're going to do is you're going to complete the square for the x's and the y's. That's what you're going to do. First things first, we're going to group the x's together. X squared plus 6x, leave some space, plus the y squared plus the 4y, leave some space, still equal to a 3. Now, STD form of a circle is x minus h quantity squared plus y minus k quantity squared equal to the radius squared, where your center is at h comma k. Now, I talked about the completing the square technique. One of the things we do in the completing the square is we find half of b, or b over 2. So here b is 6. 6 over 2 is 3. And then we square that 3, and we get 9, and we add it to both sides. Now, we're going to do that for the y piece. We're going to take 4 divided by 2. We're going to get a 2. We're going to square that 2 and get a 4, and we're going to add it to both sides. Now, the right-hand side makes 16, which is awesome. Okay? This factors perfectly as x plus 3 quantity squared. There's the 3. Plus, this guy factors perfectly as y plus 2 quantity squared. And now the thing's in STD form. Your center is at -3, -2. You see what I did with the signs? And r squared is the 16 piece. Look at the lineup process. So r is 4. Such an easy problem. It really is. If you can do a 6,000-year-old technique given to us by the Babylonians. Anywho, that is all the test. Glad I was able to finish it. I was tired of working on it today.